Good morning, this is your Stat Sensei, Mr. Spensei, and this is an assignment on regression and the introduction to some sentence stems. Our scenario is marijuana. Is it a gateway drug? So a random sample of 11 countries with the percent of people who used marijuana as a teenager and the percent of those after using marijuana as a teenager on other drugs. We're going to let you know this is the percent. This is going to be our X variable, the percent who used marijuana, and the percent who used other drugs later is Y. So did the marijuana use impact the use of other drugs? So the very first thing I'm going to do is I'm going to go back to my calculator and I'm going to make sure that I have everything set up. So I'm going to go mode and scroll down and make sure stat diagnostics is on. And I definitely want to be a stat wizard. It's on. All right. I'm going to quit out of that. I'm going to go to stat edit. And I'm going to take a moment and enter all of the marijuana use into L1 for my X's and the other drug use into L2 for my Y. Okay. And we can see that we have 11 countries marked up there. So the first thing it asks for is the Y-intercept. Well, I'm going to go ahead and run the test. So stat test letter F. This needs to be a not equal. And then I'm going to press alpha trace. And at this point, A is my y-intercept. B, we know is my slope because it's next to the x. So my A is negative 3.067. So my y-intercept, which off the calculator happens to be letter A, is negative 3.067. My slope, which will be the next thing it asks for, is positive 0.6150. And I'm going to go ahead and put a positive sign. You don't have to put a positive sign, but that ties into our correlation coefficient. The next thing it asks for is our coefficient of determination, our R squared. All right, so if I scroll down a little farther, oh, there it is, my R squared, 87.25%. Okay, this is written as a percent. And the correlation coefficient, which is R 0.9341. Now, as a reminder, if I take that 0.8725 and I take the square root of it, I actually get my correlation coefficient. Please note, because my slope is positive, my correlation coefficient is also positive. All right. And remember, this is R squared and this is just R. So our regression equation is y hat equals our negative 3.067. I know that doesn't show too well, plus our slope of 0.615x. Otherwise, the percent of other drugs equals negative 0.30678 plus 0.615 times the percent of marijuana use. All right. If we write it this way, we don't have to define our variables. Next, it says estimate the percent who used other drugs based on 25% marijuana. All right. So to estimate it at 25%, I need to plug in 25% into this equation. So let's put the equation in. We have negative 3.0678 plus 0.615, and we're putting in 25%. And we end up going, oh, about 12%, 12.3072%. All right. And it says calculate the residual for England. All right. So let's look at England. So England is this one right here. And residuals equals the observed minus the expected. Now I could calculate the expected by hand. All right. But, and this is what we did. We plugged in 40 because this was the observed value. All right. And we got a predicted of 21.53. That's my expected. All right. This is my observed. and this is my expected. So my observed was 40, my expected was 21. When we subtract those two, um, excuse me, my observed, I said that wrong. Observed minus expected. My observed was 21. This is who actually, this was the observed, and my expected was a 21. And we calculated that. And to get this right here, and I'm sorry that this doesn't sound too good, is my residual. That said, I could have done this. I could have gone stat edit, go all the way to the top of L3, blue stat, drop down to resid. And here's England. It's the third one. Oh, the third one is negative 0.5322. Guess what we got? Negative 0.532. So there we go. We can pull it straight off if we go ahead and run the residual. Calculate the residual for USA. Well, USA is the last one, and we end up getting 6.1577. So just pulling it straight off the calculator, we get 6.157. Alternatively, we can plug in the 34, and that would tell me we'd predict for the US, we'd expect 17.8, but we actually had 24. All right, so this was my actual, this is my predicted, excuse me. That's what I predict, or my, better yet, that's my expected. And what we actually observed was this. So we calculated the expected and we plugged it in, and residual equals observed minus expected, which is that. Or we can just pull it straight off the calculator, okay? Which I recommend pulling it off the calculator. Slope. Our slope happens to be positive 6.15. So I'm going to go ahead and write that as a fraction. 0.615 over 1. And remember, it's always y over x. All right? Well, what was our y? Our y is other drugs. And our x was marijuana. So there is a 0.615 increase in the percent who use other drugs for every 1 unit increase in the percent who use marijuana. And what's important about that is other drugs. Oops, I used the wrong color. It should have been yellow. My bad. This should have been yellow right here. Other drugs, that's my Y. And marijuana is my X. And I should have highlighted this as well. Marijuana is my X. Other drugs is my Y. Other drugs and marijuana, because it's always Y over X. Okay. The next one, the Y-intercept. Okay, in our case, we have a negative value, so we're not going to explain it because it doesn't make sense to have a negative 3% for those who don't. It goes down 3%. So that doesn't make sense. So we're not going to explain that one because it doesn't make sense in this case. Correlation coefficient. All right. So on the correlation coefficient, we ended up with a positive 0.934. So there's a strong positive, all right, because this is a high percentage. So there's a strong positive linear relationship between those who use other drugs. In other words, between our Y and our X. All right, so between our Y and our X. Number 4, the coefficient of determination. And we have that up here. Where is it? 87.25%. We just changed it to a percent. 87.2%, 87.25% of the variation in those who use other drugs. In other words, our Y can be explained by the changes in percent of those who use marijuana, and this happens to be our X. The last thing, our standard deviation of the residuals. And we didn't even ask for that. So let's run this test again. ST and run the test. Alpha trace. And we get 3.85. That's our standard deviation of the residuals. The standard deviation of the residuals is, and we just gave that to you, and it measures the variance of other drugs, which once again happens to be our Y, for a given uh, amount or percentage who used marijuana, which happens to be our X. All right. No, this wasn't the best video, but I certainly appreciate you watching. I hope it helped a little bit. Look forward to seeing you on the next one. Thank you.